It is officially 11:09 p.m., which means it's time for a chemistry video. We're going to be talking about limiting and excess reactants, what they are, conceptually what they are, and how they get applied to chemical reactions. To do it, we're going to start with modeling some reactions to show how the amount of reactants in products change. It's going to be kind of similar to what we've done in the past. However, we're going to be varying the amounts that we have, basically. We're going to use those models to understand and introduce this idea of limiting and excess reactants, this vocabulary term, and then we're going to start to apply them to specific reactions. It can become more complicated when we start involving stoichiometry and more quantitative calculations for them, but it's not that difficult of a concept to understand. And so I'm using this kind of picture form to get a good foundation of what the words and vocabulary mean, and then we're going to apply them to maybe the more difficult form of it involving calculations. We're going to start, this is kind of how we've modeled equations in the past. Like if I've given this balanced equation, this is how we've modeled it, where from the equation I can see I need 2 hydrogen molecules, 1 oxygen molecule, and then we're going to react and form 2 water molecules. We're going to represent that slightly different. We're just not going to use the letters. We're just going to use different color circles to represent the different atoms. Problems are going to look something like this, where these big squares are going to represent maybe a reaction vessel or reaction container. Whatever is before the arrow is going to say like before the reaction starts. Whatever is after the arrow, this needs to be a visualization of what the vessel or container is going to look like after the reaction is stopped. What I'm going to do is I'm going to take my starting contents, I'm going to paste it over. That way I don't have to change this, I don't have to adjust it, I get this before picture that's not changing, and I'm just going to make changes over here. From my equation, I can see I need 2 hydrogen molecules and an oxygen to form 2 water molecules. For example, 2 hydrogen molecules, 1 oxygen molecule, they can react. When they do, they're going to give me 1 and 2 oxygen molecules. I still have more reactants, so I'm going to keep going to see. I have 2 hydrogen molecules as needed. I have 1 oxygen molecule as needed, and it's going to form 2 water molecules, 2 more water molecules. So if this, I have 1, 2, 3, 4, example, 4 hydrogen molecules and 2 water molecules, I'll form 4 water molecules. Another example, I have varying amounts. I'm going to do the same thing, just basically copy over. And I'm going to start figuring out what I can make based on this reaction. So I have 2 hydrogens and an oxygen molecule. Those are going to react and give me 2 water molecules. I have 2 hydrogens and an oxygen. They're going to react and form a lovely 2 water molecules. I have 1, 2, and an oxygen. Will form 2 more water molecules. I have another 2 more hydrogens and an oxygen. They're going to react and form another 2 water molecules. Now looking at this container, I have 2 hydrogen molecules, but oh, no more oxygens left. Well, done. The reaction will stop because I no longer have any more oxygen left. Oxygen has basically ruined the reaction. It's caused it to stop because it ran out. I have extra leftover hydrogen. I can't do anything with it. I don't have the oxygen to react it with, so this is what my reaction vessel is going to look like when this reaction stops. I'll form a bunch of water, but I'm going to have extra or leftover hydrogen. That brings us to the term and vocabulary limiting and reactant and excess reactant. Excess means you basically had so much of it, you did not have to worry about it at all. So that, and this previous example is going to be hydrogen. We had extra hydrogen left over. An extra reactant, you have so much of it that it is left over, or you have extra at the end of a chemical reaction. So it is a reactant that you have extra or left over when a chemical reaction stops. Limiting reactant, on the other hand, is going to be the reactant that you run out of. You're not going to have any left over at the end. So it is the reactant that you run out of during a chemical reaction. As a result, the reaction stops because it limits, well, because you run out. And because you run out, it limits, because it runs out, it limits how much product you can form. That is the basic definition of limiting reactant and excess reactant. We can apply it to another example. This time it's a different equation. I'm going to do the same thing at the start, which is make a copy. And then based on this equation, I need 2 nitrogens and molecules and 3 hydrogen. 1, 2, 3. They can react, and they're going to give me 1, 2 ammonia molecules. I need 1, 2 nitrogens and 1, 2, 3 hydrogens. They're going to react, and I'm going to be left with 2 ammonia ions in their stead. I have 1, 2 nitrogen molecules and 1, 2, 3 hydrogen molecules. Those are going to react and form another 2 ammonia molecules. Now I have 1, 2 nitrogens, but looks like I have run out of hydrogen. So this reaction will stop. It can't happen anymore because I don't have any more hydrogen. Since I have extra or leftover nitrogen, that is going to be my excess reactant. Because I ran out of hydrogen, and that is why my reactant stopped, that is going to be my limiting reactant, hydrogen, H2. We call it limiting because it limits how much product, because, well, you've run out, you've stopped the reaction. That is the basic definition of limiting reactant excess, how it's applied, how these pictures can be helpful in understanding that. So I'm going to give you some practice with this before we move on to the more calculation-based stuff.